Hello and welcome back to Calculus 1. Today's lectures are on integration. We did have 4 lectures already, or 5 or something, but today's lecture is on U substitution, and in order for us to get that most important integration technique, to understand that most important integration technique, we have to first review all of integration prior to this. So let's have an integration review of integration. How about that? So first of all, integration is opposite from differentiation. We saw that in our fundamental theorem of calculus, where we stated that the derivative of the integral dt is just the function we started with. So this is the statement which shows that derivatives and integrals are opposites of one another. So in this light, if I take the derivative of x squared, I will get 2x. If I integrate 2x dx, I will get x squared. And we put plus c because we are not sure whether we started with x squared or x squared plus 10 or x squared minus 30. We have to have that plus c for indefinite integrals. Indefinite integrals are the ones that do not have numbers on top and the bottom of the integral. So they are just giving us functions as answers. And then with the definite integrals, ones with numbers, we can compute the value. So to remind you of rules of integration, integral of a constant, let me put the constant k so we don't. So integral of a constant k is equal to kx and then plus some constant c. Integral of any polynomial term, but this could also be, square root with a half exponent, or it could be a cube root with a third exponent or anything like that, is equal to xn plus 1 divided by n plus 1, and then we have plus c. We talked about the integral e to the ax, so if you have a number in front of that x, these are exponential ones, the answer is e to the ax divided by a plus c. We also said that the integral of 1 over x dx is equal to ln absolute x plus c. All of these, you see, they're backwards from your derivatives. Another integral of, what else is important? Well, trig, obviously, but is there anything else before I hit trig? I don't think so, because all of the polynomials and square roots and cube roots and all other kind of roots are there. Your exponential, you have your constant up there, and I think that's it. We can just go with the trig now. So integral of sine ax dx, so I have some number in front of x, is going to be negative 1 over a cosine ax plus c. So we know that the integral of sine is negative cosine, but if you have this a multiplying, right, that changes the period of the problem, then we get this one. And then we also have cosine ax dx. So again, the argument, I can put these in parentheses, gonna make you happy. It's going to be 1 over a sine ax plus c. Now, integral of tangent, just tangent, is not a basic integral. So we don't have integral of tangent on this list because it's not a basic integral. What we have is integral of secant squared x dx, which gives you tangent x plus c as the answer. So the derivative of tangent is secant squared. Integral of secant squared is tangent. Now we are going to compute integral of tangent by the end of the day today, and we will find out that it's some kind of ln blah blah blah. We'll see what it is once we get there. But integral of tangent is not a basic integral. Tangent is a basic function, right? But integral of tangent is not on the list of basic things. So what else you have on the list of basic things? You have secant x times tangent x dx. That's also considered a basic integral because that gives you back secant x plus c. So if you are thinking about this trig for integration, you don't get the basic ones because you are integrating what the answers for derivatives were. So answers for derivatives were secant squared and a secant tangent. So the integral of those will give you answers. So if you want to think about this, integration answers are the basic functions, where the input for integration is whatever the answers were for derivatives, because they're opposite. You also have integral of cosecant squared x dx, which will give you negative cotangent x plus c, and you will have integral of cosecant x cotangent x dx, which gives you negative cosecant x plus c. So if you take a look again one more time now, you have all of the basic functions to actually be your answers for integration. So those are considered basic integrals, which creates some issues in Calc 2. We'll see how that works when you take that course. So that takes care of the basic trig. Now I will outline one more, which shows up all the time, and that's this one. You might also see it as dx divided by 1 plus x squared, depending on which book you read. And this integral is inverse tangent of x plus c. So that one shows up, and I hope you guys will learn it. So this is the list of basic integration. One more time, we start with a constant, and then constant will pick up x because it is k times 1, and the k times 1 I can write as x to the 0, and you are technically using this formula because it would be x to the 0 plus 1 divided by 0 plus 1, and you pick up a single x, right? So that's why the integral of a constant is kx. You copy the constant k, and then you integrate that 1 as x to the 0 into x to the 1 over 1, which is x. So using the formula below. So integral of a constant is kx, and then you have the ones for polynomials. So I'm just going to say for this one, it's polynomials, but it's also roots. And it's also rationals. Because you can also have 1 over. So polynomial like x to the 7, and then roots like 5th root of x, and then rationals like 1 over x to the 3. So they all belong to that formula because you can all write them as x to some kind of exponent, right? You have x to the 7, then you have x to the 1/5, and then you have x to the negative 3. So all of those belong. It's a very powerful formula. It has a lot of integrals connected to it. So that's the second one. And then you have your exponential, then you have your 1 over x. Now, I hope that you see this interesting thing. This 1 over x kind of fills the only spot that this formula can't fill. That formula will not work with this setup here. I hope you see that you get 0 in denominator, right? So that's why this formula, but mathematics is so great that there's something else that fills that position. So if you look carefully, right, if exponent on this x is what? What's exponent on this x? -1, right? So this would be written in this form as x to the -1. X to the -1 plus 1 is x to the 0 divided by 0, right? So you see that this formula cannot work on this example. It's the only example that the formula doesn't work on. But luckily that gives us ln x. Everything else fits that formula. Pick any other number other than -1, you will be able to compute that formula. And here are your whole numbers, positive numbers, negative numbers, and then any type of fraction to give you any kind of a root. It even works for, crazy stuff like pi. Like if you want x to the pi with pi plus 1 divided by pi plus 1. Good. Then you have your trig, and then you have your inverse tangent at the end. And rules say that if you have, this is typically what we call a linearity rule. If you have integral of a times f of x plus b times g of x, all of that dx, you can kick the constant outside and split the integrals. So this is what we call a linearity rule, which allows us to solve problems faster in one shot. So here is the problem. I'm going to write it in a nicer way from the textbook. It says integral, open parenthesis, 3 cube root of x plus 4 over cube root of x plus 6 dx. So now, first of all, these parentheses here must be there. They're not there for decoration. Notationally, they have to be there because it is this times dx. Okay? That's the height, that's the width, and you get your area. All right? So those parentheses are not there for decoration. They have to keep this as one unit to be multiplied by dx. Then later, if you have limits, you can compute. If you have no limits, you will put plus c because it's indefinite integral. So now, when I see a problem like this, the first thing that I do is I rewrite these x's to show their exponents so that I can easily use this formula. All right? So I will write this as integral, open parenthesis, 3x to the 1/3 plus 4x to the negative 1/3 plus 6 dx. And now, because of the rule above, I know that each one of these can be integrated separately. So I copy 3 and I go x to the 1/3 plus 1 divided by 1/3 plus 1 plus copy 4, x to the negative 1/3 plus 1 over negative 1/3 plus 1 and then plus 6x. We know that the constant will just gain that x, right? That was the first rule we wrote. And then plus c. So now all I need to do is to fix some of this algebra. So 3 x to the 4/3 divided by 4/3. Now plus 4, we add these, which is x to the 2/3 divided by 2/3. Still plus 6x plus c. And now just deal with the double fraction. So 9/4 x to the 4/3 plus 2 and 4 will cancel. So it's going to be 6. Or you can say 4 times 3 is 12 divided by 2 is 6. Whatever. Whatever makes you happy. It's important to be happy. It's Saturday. Right? Everyone loves weekends. There, my smiles. Nice, nice. About 700 people smile now. So this would be the answer. And if you really, really, really want to show off your math skills and you want to, be really fancy, you would write 9/4 cube root of x to the 4th plus 6 cube root of x squared plus 6x plus c. Now I will box the one above because for vast majority of people and also for me when I'm lazy, that would be the answer, so I don't write the next line. But you have to, at this point in life, right, called Calculus 1, end of Calculus 1, you must know that both of these, right, are the same. And also, how would you do this problem if this was something to be integrated? Your first step is to write all of these exponents that way, right? That would be your first step, to write it this way and then integrate each one independently. So that algebra needs to be there with you at all times. So that was one of the examples to work with. Sometimes you have to perform algebra before you do the problems. So let's say you have 12t to the 8th minus t divided by t cubed dt. Well, I hope you know how to divide this, because when you divide this, you will get a basic polynomial looking integrals, and you just apply the formula. So how much is 12t to the 8th divided by t cubed? Please don't all scream at once, I can't make it out. So what was it? 12t to the 5th, thank you. And how much is negative t divided by t cubed? Yes, negative 1 over t squared, which I'm immediately going to write t to the minus 2. Now observe, parentheses now have to be there. I did not need parentheses on the first line because it was one fraction. So it is that one fraction times dt, right? One fraction times dt. So it was okay not to have parentheses. But on the bottom I have subtraction. I have two terms. So I have to put that in parentheses and then it's times dt. Now you just unleash your formula. 12 t to the 5 plus 1 over 5 plus 1 minus t to the negative 2 plus 1 over negative 2 plus 1 plus c, which further equals to 5 plus 1 is 6, so 2t to the 6 plus, because the denominator is negative 1 over t, because the exponent is negative 1, and then plus c. So do we all see that this is negative 1, right? That changes the negative into a positive. And then exponent is negative 1, so t to the minus 1 is 1 over t. And that take care. Oh, this line is terrible. We just gave up at the end. All happy? 700 people. All happy. Ooh. The famous Dame problem. Okay, let's see. Integral of 5m times 12m cubed minus 10m dm. I mean dm. Can we integrate each one individually? Hell no, right? Hell no. What do we have to do first? Distribute. We must distribute first because there is no, I mean, the rule for multiplication is called integration by parts and also u sub, and there are a few ways in which we deal with multiplications. You cannot integrate multiplication simply. You have to get this. So integral of 5 times 12 is 60. Okay, looks like those calculators are working just fine. And then minus 10 times 5 is, okay, m squared. I still have to have these parentheses and then dm. I mean dm. You'll be okay? All right. And now we have to integrate. So that would be copy the constant 60, m to the 4 plus 1 over 4 plus. Now, guys, if you don't need this 4 plus 1 plus 1, just skip it. No one cares. Just give me the final answer right from here. It's okay. If you are at that stage already. You are definitely expected to be at that stage the first day of Calc 2, whatever that is, in the summer or in the fall. So if you don't need this plus 1 stage, feel free to skip that stuff. 60 divided by 5 is 12m to the 5 plus 50 thirds m cubed plus c, and that's it. That's enough of that formula, I hope. Let's see how much you are enjoying your trig. So how much is the integral of sine 2y plus cosine of 3y dy? That's easy for me. That's how I am all the time. And then when you poke holes, then you smile. Yeah, exactly. Exactly. Yeah. Yeah.
What kind of party?
We'll see. Whatever it is, they figured out. We'll have to change it to someone. Gonna get handcuffed to somebody who's going.
No, because I followed the thread on India, but I'm tired. I have a lot of, I have to pre-read Amanda's essay, and he essay that I need, so.
You have to?
Yeah, for switching, I have to do mine, so.
Yeah, but you have Sunday.
No, but she needs advice of finishing it up for after where she's not available for me, so.
Well, you will do that, and you will do the other. You will try to change it. You plan for it. But Override has to have parties more often because you guys don't party enough and then you are not. No, I'm serious. The hell. We used to party.
I just went to a sweet 16.
Yeah.
Yes, sir.
But see, I mean, we need the Override party. That's a private party that has nothing to do with Override. All right, so I hope you have those. So you know the formula. Anytime you have a number in front of the variable, that will be a fraction. So we have sine goes into negative cosine, so it's negative 1/2 cosine 2y. Cosine goes into positive sine, so it's going to be 1/3 sine 3y plus c. Now I have an evil question. And the evil question is integral of tangent squared x dx. This is a really evil question for Calculus 1. You are going to have a section in Calc 2, Chapter 7, I think it's 7.3, trigonometric integrals, where you learn how to deal with any crazy stuff. You know that tangent is not a basic integral. I told you that earlier. And you also know that then in that case tangent squared should be even worse, right? Even if you're thinking about the power reducing formula, which you most likely don't remember. Could we do something else? Yes. Unfortunately, I mean, it is that's it. You can write it this way, or you can write tangent x to the square. That one. So if you should constantly go through your head is what can I integrate? I can't integrate that. But what can I integrate? And then when you're looking at the list of all the trig things that you can integrate, you say, oh, there's that Pythagorean identity that involves tangent squared, secant squared, and 1. You can integrate 1. You can integrate secant squared. So if you are to rewrite that tangent squared through this identity, this is why what makes trig a little bit crazy for integration, and why we have 2 sections about trig integration in Calc 2. You have to figure out how to rewrite it so it can be done. So we know that, and I'll write it here on the side because again you're reviewing, but you better know this for Calc 2, is that tangent squared x plus 1 is secant squared x. So now this integral, using this identity, changes into secant squared x minus 1, in parentheses obviously dx, because we have to multiply both of them. Now, the integral of secant x is tangent x, and the integral of 1 is just x, and you have plus c. So, my young Padawan learners, use the force, the identities. So let's brush up on those identities. How about integral secant 4 theta tangent 4 theta d theta? Good morning. Oh, actually, hold on. This is not identity. It's basic. Right? If you look at the list, this is the basic one. What's the integral of secant tangent? Secant. So 1/4 secant 4 theta plus c. That was basic. Sorry. Much better. The integral of sine theta minus 1 divided by cosine squared theta. There we go, much better. D theta. Much better. All right, I have a question before we, just to go back. So if you can see 4 and a 4, so there is a 4 here and then this quarter because of that 4. If you look at the basic formula, I didn't have that because I didn't want to clutter it. The same thing happens with the sine and cosine. If there is an a in front of these x's, even for these other formulas here, it will pop up as 1 over a. So our formula was this with a 4. So it's going to be 1 over 4 and then 4 again. Bueno? No. I will leave it for longer than a second. because I don't think you can write it in a second. You know how critical I am of your skills.
Yes. Okay. I know. I make it big and I make it better than I make it worse. You should say it that fast. Okay. Alright, don't say it. Because people get to stay inside and do like cool things with confidence. Events was outside and
Who goes to the beach?
I lost my everything. Cool. Yeah, no, sure. And then something else terrible happened today, but I don't remember what. So.
Does someone take offense to it?
Yeah, probably. Someone has to take offense. Yeah. I'm just gonna. We're gonna be sitting in class, and I'm just gonna start screaming.
And put all of this awesome stuff in it, and then you go outside. Scorching sun and rain.
I got face that.
That's fine.
Because I'm gonna be here all week today, and I never know more. But thank you.
There is no need to go outside unless you have to buy food. You don't have to hunt, you don't have to, right?
You don't have to hunt, but
There are farmers that will grow food for you, right? just do work from home and just watch. Now with even the ShopRite thing, you don't even have to go outside to buy the food. You can just punch everything on the computer and drive it to you.
See, that makes me feel fat just thinking.
You open the doors to put the bags in. That's it. Close it. That's it. Like no need to travel, right?
Yeah.
Or like travel, right?
That's why we need virtual reality, so we could just like be really lazy.
Yeah, how you doing with the kids? You love them as well?
No, I don't.
Or spiders?
That's why you have Bugs Spray. I don't like. I don't care.
Bug spray usually doesn't work. It's not that great. If you wear deep deep woods or something like that, that's really good.
I don't really care about bugs. I don't care about. Like, as long as it's not ticks.
It's like
I don't care about spiders.
woods or something like that. I don't know. I really good.
Okay.
My mom makes
I'll be
us spray
ready.
bug spray on before we go to the computer. Like our Portland
Okay.
family.
What kind of movie theater you go to?
Like bed bugs or something?
Yeah.
Like,
Bug spray is repellent against bed bugs.
Oh, deep woods.
I just have another reason not to go to movie
I'm
theater. I never
just-
thought of that.
I'm just laughing at
Because
Ellen's family
apparently,
now.
no, because apparently, like my mom's friends, like that's how like they got
Got
like,
bed
she
bugs
got
from
bed
them.
bug- Yeah, me.
I think that's an
They
excuse.
treated
Like,
the
she was
whole-
probably sleeping at some scuzzy guy's house. And it's like, yeah, honey, I
No,
got
it's
these
like-
from the movie theater.
All right,
Later, the whole-
let's solve this problem.
Which is so-
Because way too many people probably solved the problem, and now we're talking about bugs and yes. You had a question? Oh, solved it? Would you please enlighten us all? No, I mean you actually teach the problem with the yeah. So here, this is gonna be official interview now, on my part. So, let's see the math skills. Now, how do you check every integration problem? You take the derivative. So it just, if you're not lazy, you will take the derivative. If you get what you started with, you're good to go. All right, so it looks like Stefan is going to break it into two integrals. Because you have a minus sign in the numerator, it breaks into two fractions. Good use of parentheses because both of those fractions have to be times d theta. And then you have further sine over cosine is tangent, and then 1 over cosine, because you have two cosines on the bottom, right? So we have those two. Where's the applause? Oh, actually, hold on, no applauses because the markers fell apart.
Sorry.
Well, that's okay. It's my exercise for today. And one. I do. At most 2 reps per day. You don't want to injure the back or something. No. 2 reps a day is enough. The rest is video games. Right? Right. Great. I did not think this through. Now I still have to write it. Should have written it on the tablet. All right, so that's perfect. We are going to, we are going to split sine theta over cosine squared theta minus 1 over cosine squared theta in parentheses. And because we know that the cosine squared is the common denominator. What do you mean common? Common for both fractions. So each fraction gets its own cosine squared. Then that further breaks into sine theta over cosine theta and 1 over cosine theta minus 1 over cosine squared theta. And now you have integral of sine over cosine is tangent theta minus, nope, tangent theta 1 over cosine is secant theta minus secant squared theta, still in parentheses d theta, and now each individual integral is tangent theta, secant theta, that's a secant theta minus tangent theta plus c. So either put plus c or minus 1. That. All right, that's enough of the trick. How about this one? E to the 2t plus 2 square root of t dt.
Here, let's do.
And then together become a plus. Get close to the guys. I know. That is annoying. Well, you can always roll back while you're doing it.
Okay, let's take a look at this problem. So we have e to the 2t. We have a number in front of t. That means that it's going to be 1/2 in front. And then we have plus copy t to the 3/2 divided by 3/2 plus c. The final answer 1/2 e to the 2t plus 4/3 t to the 3/2 plus c. So I hope that's what you guys have. Did you cancel those twos?
No, no,
No,
no.
Oh,
it's Charlie.
Oh, you forgot about Charlie?
No, no.
Oh, not chocolate free.
Yeah.
I worked very hard for like 3 days. It was just Charlie in my head, so I filtered it, and I hope no one would remember it, and we did.
I don't know why.
Charlie tilts you?
Yeah, it just
What's the
I
cereal?
hate it. No, it's a C. C.
All right, one more, and then we are going to move to definite integrals, the one where we calculate limits. So let's go with t plus 1 over t dt. Yo.
Can you explain something to me about the not the last problem, but the last problem? Not that one, but the one before that. Okay, so you broke it down again into 1 over cosine squared for the second line down.
I just copied this. That's a copy.
Okay, so sine
So
cosine squared.
there is a cosine times cosine, which is cosine squared here. So I can write this as sine theta times 1. And then there's a multiplication of these two. Fair? Awesome. All right, so this is going to be the last indefinite integral, and then we're going to go on. So we're pretty much using the same thing, right?
Hey, Professor, would you mind just opening all the homeworks again?
Please.
Thanks. That's all you have to do.
Yep, I would mind.
That's all you have to do. It'd be a good study. Good.
Yeah, so
I
gotta study for it.
Oh my god, I can't say a word.
That's good. There we go. The first part of my final helpful. The first part of my final this class we don't have one to do now. Oh, God.
Oh, yeah.
Sounds like that one. No, it's not. I'm good at memorizing any bullshit.
I'm so right on mine.
Alright, then
I
you
hate
gotta.
acronyms, everything. I hate acronyms.
I guess this problem too easy, right?
Yeah, we're already done. What are you doing?
I have something. All right, so the integral of 1 is t, plus the integral of 1 over t is? That's the one. If you don't have absolute values, your problem is wrong.
Plus Charlie. Plus.
Yes, plus Charlie.
I hate myself so much.
That's okay.
That's not what Wolfram said. Wolfram calls it minus log d.
Oh, that's like
Wolfram is wrong.
For what?
quick. Fix their error and make.
Oh, maybe if you put plus in the up there, it will be correct. If you put plus here, then it will be the same answer. Definite integrals. You know what? I'm just gonna walk up there and check that.
Well, because let him post their thing. She's not going to post it till Monday. Yeah. Noon and Ian
Okay. The next part is the part on definite integrals. We are also have to integrate here to find those antiderivatives. But in addition to that, we have to compute limits. We compute limits when we integrate from a to b some function. Let me actually use x. We come up with the antiderivative, and then we compute the antiderivative at the upper limit first, and we subtract the lower limit. So this is what we have for our computation. To solve probably one of the easiest problems would be, let's say, 3 to 8 of x dx. So the integral would be x squared over 2. And then we put this vertical line which reads compute from 3 to 8. Then we will have 8 squared divided by 2 plus 3 squared divided by 2. 8 squared is 64, divided by 2 is 32. Why do I put plus? Minus 9 halves. So 64 minus 9 is, very good,
55.
over 2. So answer is 55 over 2. Let's see how much is the square root. So integral of the square root of x divided by 3 computed from 4 to 16 dx.
Yeah, I was gonna say, is that when you went over to, when he was,
No, this looks like Linearity Rule here.
it's just something he picked up and then he brought it over here.
I hear it.
See, I would love to see you live in this. And this is what you say the jumpsuits.
We will. We have to. It's the Slav way. So we have 1/3 x to the 3 halves divided by 3 halves computed from 4 to 16. 3 and 3 will cancel. So this becomes 2 square root of x cubed from 4 to 16. Now you can choose to take roots first and then cube later. So you can have it like this as well, if you want to, which is better, obviously. So 2 times square root of 16 cubed minus square root of 4 cubed, which is 2 times 4 cubed minus 2 cubed. 4 cubed is? Very good. And then 64 minus 8 is? Sure?
112.
Yep. Integral of sine x over 2 plus cosine x dx computed from 0 to pi over 2. Yes.
I could be wrong, but I think the algebra for the last one was off. Maybe it's 2x to the 3 halves over 9. I don't think the 1/3 happens. I think it's 1/9.
No, it's gonna be 1/3 times. Oh, that's 2 over 9. So that's 2 over 9. Oops. Not paying attention. Now 1 plus 1 is 2 plus 2 is 4. 4 is not divided by 9, so 112 over 9 stays. Very good. Yeah, I was just testing you. And you all failed except Eli.
No,
Yeah.
I wanted Eli to get the spotlight. I actually knew what the answer was.
Okay, fine. You say no coffee.
You should write that on the syllabus for next semester.
I guess. Well, per syllabus, it says no coughing. So this one is probably a little bit more annoying on the arithmetic side, but it shouldn't be labeled as hard, definitely. So we go and say integral of sine is negative cosine, and then x over 2, right? But then the coefficient in front will be 2, because it will be 1 over 1/2, right? So that's 2. And then plus sine x computed from 0 to pi over 2. So we are going to plug in pi over 2, which makes it into a negative 2 cosine of pi over 4 plus sine of pi over 2. Minus and minus will give me plus cosine of 0. Sorry, 2 cosine of 0. And then minus sine of 0. Cosine of pi over 4 is root 2 over 2, so this is negative root 2. Sine of pi over 2 is 1, so plus 1. Cosine of 0 is 1 times 2 is 2. And then sine of 0 is 0. So the whole thing is 3 minus root 2. Till Eli fixes it. You agree with this one? All right. Oh, you missed this one? All right, so now we're 1-1. I'll keep a tally over here. Except I have 30 minutes, or 40 minutes head start. I'll just keep a daily tab. Would you like to give a presentation?
In a bit. I'll
Yeah.
let us handle the small stuff first.
All right, let's restart the stream for the lecture. So this was the review. We'll restart the stream for the lecture. Stop.